It's your friendly math tutor, Miss C here, and today we are solving equations for the variable x. When x is in the denominator, I'm going to start by dividing my equation into two sides, and I do that by drawing a vertical line through the equal sign. So now I have a left side of my equation and a right side, remembering that what we do to one side of an equation, we do to the other. All right, I've written PEMDAS for us up at the top. That's the order of operations. Because we are solving an equation, we are working PEMDAS backwards from left to right, starting with addition and subtraction. Now, for my first equation, I'm going to notice that x is in the denominator. And my goal is to get x by itself, which means that we need to start by getting this term 24 divided by x by itself. So I am looking for any addition or subtraction I can do to that end. And I've got this subtract 8 here. So I'm going to move that over. I'm going to do the opposite of subtracting, which is adding 8 to both sides. All right, when I do that, I'm left with 24 divided by x on the left side and negative 4 plus 8, which is 4 on the right side. All right, now I'm looking for multiplication and division that will help me get x by itself. I'm noticing that x is what is being divided. The opposite of division is multiplication, so I'm going to multiply both sides by x. Okay, and just a little hint, there's technically a 1 underneath this x. So if we were going to do this absolutely mathematically, I could say that I'm going to multiply numerator to numerator. So x times 24 is 24x. 1 times x is x equals 4 times x, which is 4x. By the way, there's a secret 1 underneath all of these. 1 times 1 is 1. We don't write that in math. What I can now see on my left side is the reason this moves x to the other side is because x divided by x is 1. So we end up with 24 times 1, which is 24, equals 4x. There are no exponents left, or there never were exponents. There are no parentheses. I'm back around to addition and subtraction. There's no addition or subtraction. I'm back to multiplication and division, and I have multiplication 4 times x. The opposite or the inverse operation of multiplication is division. So I'm dividing by 4 on each side, and x equals 6. So let's just double check that we did this correctly. So here's my check. Everywhere I see x, I'm plugging in the number 6. Okay, so now I have 24 divided by 6 is 6. 6 minus 8 is in fact, oops, let me try that again here. That would have been wrong, except 24 divided by 6 is not 6, it's 4. 4 minus 8 is negative 4. So yes, that answer is correct. Our next problem, we have x in the first term's denominator, 2x in the second term's denominator. There are several correct ways to do this. But because I like the most efficient way, the thing that I'm going to do is I'm going to multiply this whole equation by x. Okay, so that means I'm going to distribute x to this term. I'm going to distribute x to this term, and I'm going to distribute x to this term. And really, I'm distributing x divided by 1 to each term. So when I do that, I end up with x times 48, which is 48x, over 1 times x, which is x, plus x times 30, which is 30x, over 1 times 2x, and then x times 21, which is 21x. And then what's secretly under this 21 is 1. So 1 times 1 is 1. We don't typically write ones underneath our whole numbers. So I'm just going to leave that as 21x. Now, what you're going to notice is that I have x divided by x here. Well, that becomes a 1. So I now have 48 times 1. I have x divided by x once again, which is 1, and then just 21x. So what I've done by multiplying this whole equation by x is I ended up getting x out of the denominator, which was my goal. So I'm going to now simplify this left side here. So I end up with 48 times 1, which is 48, plus 30 divided by 2 times 1. So what is 30 divided by 2 is 15. 15 times 1 is 15, equals 21x. And I guess I should have like divided my equation vertically with that line again, but if you don't like to do that, this is how you do it anyway. So now I'm going to go ahead and add these two numbers together. Oops, I dropped my 21 there. 48 plus 15, if I'm doing this in my head, 48 plus 10 is 58. 58 plus 5 is 63. And that equals 21x. You're going to notice that I'm lining up my equal signs here. Being neat is part of how you are accurate in math. All right, now I have 63 equals 21x. So 21 is being multiplied by x. So I'm going to do the opposite of multiplication, which is division. So I'm dividing by 21 on both sides. When I do that, I get 63 divided by 21 is 3 equals x. All right, let's just double check that we are correct. So everywhere that I see x, I'm putting in 3. So I'm going to put in 3 in blue. Plus. Okay. And then that equaled 21. So let's just do this really quick. 48 divided by 3 is 16. Plus 30 divided by 2 times 3 is 6. So it's 5. 21 does in fact equal 16 plus 5. So that answer is correct. All right, our last equation, we can go ahead and divide this down the center. We are still using PEMDAS, but we once again have our issue of having x in the denominator and not just in one denominator, both. What's different about these two problems is that the x's are on opposite sides of the equal sign, and there aren't other terms being added like there was here. So what I can actually do is instead of multiplying the whole equation by x, which is what I did in the last problem, which I could totally do, I'm actually going to cross multiply. You can only cross multiply when you have an equal sign here. Okay, so I'm going to multiply 6 times 4x, and that gives me 24x, equals 8x times 3, which is 24x. So 24x equals 24x. What this means is there's infinite solutions because anything I plug in for x is going to make this true. Now, part of the reason that's true is you might have noticed when we started doing this is 6 over 8x is actually the exact same value as 3 divided by 4x, which means that any value you plug in for x will be true. So I could plug in 10 for x, and that would make this true. I could plug in 1 for x because it's the same fraction. All right, there you have it. This is how you solve equations for x when x is in the denominator. If you found this video helpful, please like it so that other people see it in their feeds. Make sure to subscribe so you don't miss a video. And remember, till next time, you've got this.